Welcome back to the channel. Today on this video we'll be doing this question paper that you see here. This question paper is mathematics and 4, which was written on the 24th November 2025. It was an X paper that took 3 hours to be written. So we already done question 1, question 2. So on this particular video, we'll be focusing on question 3. So if you want to watch question 1 and 2, I'm going to leave a playlist that contains those 2 questions on the description of this video and also on the top right of the video that you're watching at the moment. And before we begin, I'm also going to create some timestamps so that you can watch a specific question if you don't want to watch this question paper in a sequence order. Now, before we start though, I'd just like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. All right, people. So let's look at question 3 and let's start solving it. All right, here's our question 3. Question 3 is based on trigonometry. So it has 5 questions. We're going to start with 3.1 and then we're going to do other questions afterwards. So let's create space so that we can do 3.1. All right, here is our question 3.1. Now, this question here, they want us to simplify as far as possible. If you are given this expression here, now here, guys, it's when we simplify the trigonometric ratios using methods to reduce and simplify further. So, in order for you to do this problem or to solve this problem, you need to know the cast diagram when it goes forward and backward, or when it's clockwise and when it's anti-clockwise. So I'm going to write the cast diagram here on our right hand side so that we can able to refer as we are solving this problem. So let me just write these 2 cast diagrams for the positive and the negative. All right, this is the cast diagram when we are moving in this direction here. When we're moving in a clockwise direction, the 4th quadrant, we represent it this way. It's going to be negative x in this case. We use x because we have x on our problem. So please don't forget that. Okay. And then on this one here, on the 3rd quadrant, it's going to be negative 180 plus x. That's how we present the 3rd quadrant when you go backwards. The 2nd quadrant, when you go backwards, this is how we present it. It's going to be negative 180 minus x because you're going backwards. And then the 1st quadrant, when you go backwards, it's going to be negative 360 plus x. So this is how we represent the quadrant when you go backwards. Now let's draw the cast diagram when it is positive, or when we are going on the positive side of the cast diagram. All right, so on this cast diagram, we're going to be moving on an anti-clockwise direction, or on the positive side of our angles. Now on the 1st quadrant, when you're moving on the positive side, this is how we represent this quadrant. It's just going to be x. Remember, we're using x because our question has x there, right? Please don't forget that. But usually we use theta on such. Our 2nd quadrant, when you go on the positive side of the cast diagram, it's 180 minus x. And then our 3rd quadrant is going to be 180 plus x. And then our 4th quadrant is 360 minus x. So these here are the cast diagram. Again, I need to add on something here because our question, it is 180 and 360. You're going to use the 180 rule. I'm going to leave a video that explains the 180 rule on the description, and also that video will pop up on the top right of this video that you're watching at the current moment, that explain how to use the 180 rule. Let's start with our first trigonometric ratio on the numerator. Then we have tan x minus 180. So I would say to you, rewrite this like this: tan, right, negative 180 plus x. This here will help you to understand which quadrant exactly is this one. When it's like this, it's a bit confusing. So try to rearrange these inside them. And then you're going to continue, rewrite sine 180 plus x multiplied by cos negative x. And then on the numerator, again, there's something that we need to do here. We have sine squared 360 degrees minus x. So the problem here is the squared here. If you don't understand your math very well, you might make some mistakes. So here's what I would advise you to do whenever you come across a trigonometric ratio that is squared in such a problem. So you rather write sine 360 minus x multiplied by another sine 360 minus x. This means that if they are multiplying like this, they are squared, as you can see on the denominator of this question that we are doing here. Now that we have made our question to be easy to simplify, now let's use our cast diagrams to reduce this. Like I said, we're going to use the 180 rule. So the 180 rule, I already left the video on the description. First of all, look at your quadrant here. So what quadrant is negative 180 plus x? Since our 180 is negative, this means that we are going backwards. So we must look at the red cast diagram. So negative 180 plus x is actually on the third quadrant. So on the third quadrant is tan positive or negative. We know that tan is going to be positive. So we're going to write tan x. There we go. Plus, now we move to the other trigonometric ratio, which is 180 plus x. Now 180 plus x, this is when we are moving in a positive direction or in an anti-clockwise direction of angles. So basically we're going to look at the blue cast diagram. Now 180 plus, when you look at the blue cast diagram, is the third quadrant. Now on the third quadrant, we know that sine is not positive. So when you reduce this, it's going to be negative sine x. There we go. Multiply by. Now we know that we have this here, which is cos negative x. So this here, for the fact that we have negative x as an angle there, it means that we are going backwards. So when you're going backwards, we'll consider the red cast diagram. Now if you look at the red cast diagram, negative x is on the fourth quadrant. And on the fourth quadrant, we know that cos is positive. So when you reduce here, it's just going to be cos x. Please, guys, don't get confused here. And then we divide there. There we go. So as we divide here, underneath we have sine 360 minus x. So when we look at 360 minus x for both of these two trigonometric ratios, we can see that this is when we are moving in a positive direction. Now the positive direction, we have to look at the cast diagram that is blue. As you can see, 360 minus x is actually on the fourth quadrant. Now on the fourth quadrant, the only trigonometric ratio that is positive there, it's actually cos, and it's inverse. So meaning sine is going to be negative. So for this one, it's better to reduce this one first. If you reduce it, it's going to be negative sine x multiplied by another, this one here, negative sine x. Because if they multiply each other, this is going to give you what? Positive. That's the reason why we decided to separate them like this, right? Some of you can able to see this without separating. It's still fine. But if you're not so sure, separate. So let's create space and let's solve this further. As you continue here, now as for tan x, we're going to write it as tan x. So we're going to multiply this negative sine x with cos x. So this is going to be negative sine x multiplied by cos x. There we go. And then we divide them. As we divide, we have negative sine x multiplied by negative sine x. This is going to give us positive sine x squared, or sine squared x. There we go. Now let's continue. You can separate this. You can write tan x over sine squared x minus sine x multiplied by cos over sine squared x. This is allowed, guys, as long as this line here, it's solid. Just know that this is allowed. So let's create a little bit of space here as we continue. Now the first one here, which is tan x divided by sine squared x, we can rewrite it like this. We can say, instead of writing tan on the numerator, we can write sine x over cos x. This is what you call the quotient identity, right? I hope you know tan is the same as sine over cos x divided by sine squared x. This sine squared x then, and then we say all this here, let's put it inside the brackets. It's minus by sine x multiplied by cos x divided by sine squared x. So as you can see, we have sine squared here divided by this sine. So what we'll be left with here, we're going to be left with cos on the numerator, divide by sine x. So for now, we're just going to leave it like this. Now, if you continue further, we have sine x divided by cos x, right? If we change this into multiplication, this division here, we know that our sine squared x is going to be dividing them. So it's going to be 1 divided by sine squared x. There we go. Remember, when you change this division into multiplication, the numerator become the denominator and the denominator become the numerator. I hope you know about this. It's a basic information. Right, so from here, we're just going to write this as it is. Cos x divided by sine x. There we go. Then from here, again, since we have multiplication here, we can say this sine and that sine can divide each other. So what basically are you left with here? You're only left with 1 over cos x multiplied by 1 over sine x. Right, let's put this inside the bracket minus this one. We're going to write it as it is, cos x divided by sine x. I hope you guys can see. Let me create a little bit of space here because this is very long. All right, let's look at the first bracket. Then when you look at the numerator, we have 1 multiplied by 1. So we're going to have 1 on the numerator. Then on the denominator, we're going to have cos x multiplied by sine x. This is going to give us cos x multiplied by sine x minus. Now the second term here, we know that it's going to be cos x divided by sine x. When it's like this, we need to find our LCD, which is going to be cos x multiplied by sine x. Now we're going to divide this cos x sine x with that cos x sine x. This is going to give us 1 multiplied by that one there, and that is going to give us 1. Then minus that minus there, and then we're going to divide this cos x sine x with that sine x. It's going to give us cos x. Then we multiply that cos x with this cos x there. So this is going to give us cos squared x. There we go. Now when you look at the numerator there, we have 1 minus cos squared x. So we can use this identity when we have sine squared x plus cos squared x. This is going to give you 1. We can make sine subject to the formula. As you can see here, we can say sine squared x is equal to 1. If we transpose this cos squared x to the right hand side, this is going to give us negative cos squared x. So instead of writing 1 minus cos squared x, we can substitute with sine squared x. So let's do it on the numerator then. So we're going to write sine squared x divided by cos x multiplied by sine x. So sine x and sine x there, they're going to divide each other. On the numerator, do not forget we have sine x squared. We have sine squared x, so we're going to be left with sine x there. And then on the denominator, we're only left with cos. So as you can see, we're left with sine x over cos x. This here is a quotient identity. So sine x over cos x is the same as tan x. So this here is our final answer for this question. As you can see, guys, this question here required us to know our identities, the square identities, the quotient identities, and also the cast diagram. Just in case you don't know much about this cast diagram, you can go to the description. I left the video where I talk about cast diagram, and the very same video will pop up on the top right of the video that you're watching at the current moment. So if this video helps you to understand how to simplify such questions, do not forget to like, share, subscribe to the channel if you haven't subscribed, and also comment on the comment section if you have anything to comment about. But if you didn't understand, you can always rewatch at the point where you got lost, and if that doesn't help, you can leave a comment in the comment section. All right, people, we are done with 3.1. Let's go and do 3.2. All right, people, let's look at 3.2. So 3.2, we are given the following expression there. We're given 3 cos squared x plus 11 sine x plus 1, all this is equaling to 0. So they want us to solve for x, and also given the domain here where we have negative 360 to 360. So when you look at this basically means that we have two cycles. So before we solve this, let me draw the cast diagram so that I can show you what is the meaning of all this. Now let me use different color so that you can able to see. All right, let's look at this cast diagram. I hope you can understand what is happening here, but I'll try to explain. Now I'm gonna highlight the ones that are negative with blue. So from here, which is the 0 point, in this case now it's negative 360 degrees. We are moving in this direction, by the way. As we are moving in this direction, from negative 360 degrees to negative 270 degrees to negative 180 to negative 90, and then back to 0. And this is when we move from negative 360. Remember, we are moving from negative 360 to 360. Now from 0, we are moving to 90, 180, 270, and then 360. Like I said, we have two cycles, so we circle it two times here. Right, so let's look at our problem here. First of all, we need to simplify this so that it can become our trinomial. Now when you look at this problem here, we have cos and also we have sine. Then we need to change one of these to be like the other, meaning we need to have the same trigonometric ratio when it's like this. Now the one that we can able to change, it's cos squared x. Remember, cos squared x plus sine squared x, all this is equaling to 1. So we can make the cos squared x subject to the formula. So what can we do here? We can write cos squared x is equaling to 1. Then we transpose this sine squared x to the right hand side. It's going to become negative sine squared x. So instead of writing cos squared x, we can write 1 minus sine squared x. So let's do it. So if you look at our question, we have 3 already. So open bracket, wherever there is cos squared x, we're going to insert 1 minus sine squared x based on this one here. I hope you guys can see and understand this. Right, so let's continue. Plus 11 sine x plus 1. All this is equaling to 0. Right, so we need to remove the brackets. Obviously, if you remove the brackets, we're going to have 3 minus 3 sine squared x plus 11 sine x plus 1. All this is equaling to 0. Right, so from here we deal with the like terms. If you look at this 3 and that 1, they can add each other. So you'll be having 3 plus 1, that's going to give us 4. So if you rewrite this, it's going to give us negative 3 sine squared x plus 11 sine x plus 4. All this is equaling to 0. Then we need to change this negative to positive because our a there, it's negative. So if you multiply by negative throughout here, you're going to have positive 3 sine squared x minus 11 sine x minus 4. All this is equaling to 0. As you can see, this now is our trinomial. Now we can able to factorize this. Now we need to find the factors of 3 sine squared that when we subtract, they're going to give us negative 11. Right, and the factors of negative 4 that when we subtract, they're going to give us 11 then. So let's start. If we open the bracket, you can write 3 sine x like that. There we go. Close bracket for now. Open another bracket where we have sine x. If you multiply this 3 sine x with sine x, they're going to give us 3 sine squared x. So the factors of 3 sine squared x, we have them. Right, then let's close the bracket. We need to find the factors of 4 and insert them on these brackets so that when they subtract, they're going to give you 11. This 11 here in the middle. So let's try it. Now, if we put 1 and 4 there, right, let's see if this is going to help us, because we know that if we say 3 sine x multiplied by 4, it's going to give us 12 sine x. If you multiply these two here, going to give us 12 sine x. If you multiply 1 with sine x, it's going to just give us sine x. Now, since we want to have 11 here, it means that this 12 is going to be negative. So if we say 12 sine x minus sine x, that's going to give us negative 11 sine x, which is the one in the middle. So this means that this 4 is going to be negative, because if you multiply this 3 sine x with negative 4, it's going to give you negative 12x. So this is going to be positive. There we go. If it so happened that you couldn't do it this way, use the quadratic formula, guys. It's also accepted. This is going to be equaling to 0. Now let's continue with this one. It's going to be 3 sine x. All this is going to be negative 1, because if you transpose this one here to the other side, it's going to be negative. And the other one there, we have sine x, all is equaling to 4 there. Now if you continue and then we make sine survey formula, we have to divide by 3 on this one here. If we divide by 3, we're going to be left with sine x is equaling to negative 1 over 3. And then the other one, it's fine. We have sine x is equaling to 4. Right. So let's look at the one that is having negative 1 over 3 there. Now, when we have something like this means that our sign, it's negative. First of all, we need to highlight the quadrant where sign is negative. So what are those quadrant where sign is negative? So I'm going to highlight with green there on the cast diagram that I just created earlier. So we know that sign is negative on the third quadrant and the fourth quadrant. We are fine with that. But now we need to know, when we go backwards, how do we represent these two quadrants? We know that when you go backwards, this quadrant here is represented like this: negative 180 plus x, right? This is when you go backwards here. When we go backwards on the fourth quadrant, this here is represented by negative x. We are all good. Now let's use yellow to show when we go forward. Now when you move on the positive side, this third quadrant, this is how we represent it. It's going to be 180 plus x, right? And in the fourth quadrant, it's going to be 360 minus x. There we go. So since our sign is equaling to negative 1 over 3 on this one, we need to find the reference angle. Guys, whenever you have something like this, whenever you have a trigonometric ratio which is equaling to a negative answer, just know that you need to find the reference angle first. So let's find the reference angle. Let's zoom down so that you can have space. I hope you can still see, people. So let's focus on this one here. So when you find the reference angle, you're gonna remove this negative there and write it as if there is no negative there. So you're gonna write sine x is equaling to 1 over 3. There we go. And then we find our x. Remember, when we find our x, we're gonna transpose this sign to the right hand side, and it becomes arc sine 1 over 3. So arc sine 1 over 3, it should give us a positive answer, which is going to be a reference angle. So let's use our calculators and let's insert it there. So when we insert this, it's going to give us 19.471 degrees. So here, guys, this is our reference angle. It is not the actual angle that we are looking for here. Remember, we said we're only going to focus on the third quadrant and the fourth quadrant for this one here, right? So let's do it. So on the third quadrant, can I write that here? Now we're going to have two answers here, because one, it's when we are moving in the backward direction, which is highlighted by green there, when we have x is equaling to negative 180, this one here, plus x. But our x, what is our x? Is 19.471. So x here is going to be equaling to negative 60.57 degrees. So this is one of the answers. This is when we go backwards. Now when we go forward, like this one here, still on the third quadrant, we're going to say x is equaling to 180. This time around, it's plus 19.471. And then our x here is going to be 199.47 degrees. So we have these two x's, 1 and 2. This one here is the answer for moving in a backwards direction, and this one here is the answer when we are moving in an anti-clockwise direction, which is the positive direction, right, on the third quadrant. Now we are not done, people, because we need to do the fourth quadrant. So let's do the fourth quadrant. So when we do the fourth quadrant, remember guys, we are only considering this one here that I highlighted in blue, guys, at the moment, right? So sign is negative there, so we have this one that is green. We said x is gonna be negative there because we are moving in a backwards direction. So basically this means that our x is gonna be negative our reference angle, which is gonna be 19 comma 471. So this here is also our answer as well. This is when we are moving backwards. What is our x on the fourth quadrant? Now when we are moving forward, you're going to consider 360 minus x. So x is going to be 360 minus 19,471, and then our final answer for this one is going to give us 340,53 degrees. So these two here are the answers on the fourth quadrant when it's going backwards and when it's going forward. I hope you guys understand this because it can be very, very tricky. And all these four answers are when sine x is equaling to negative 1 over 3. So these are the answers when our sign is negative. Now that we're done with that one, let's focus on this one here, which is sine is equaling to 4. Now, if you say, let's continue here. If you say x is equaling to arc sine 4, this here is going to give us an error, so there was no need for you to continue on this one. So these four answers, those are our answers for this question here. So I hope you guys managed to understand this. This is a bit tricky, so if you didn't understand, go to the point where you did not understand, rewatch it. And also, if that doesn't help, you can always leave a comment on the comment section. I'll try to explain to you to my level best where you got stuck. Again, I also made videos on how to solve for x using trigonometric ratios. I'm gonna leave those videos on the description so that you can able to understand, and also those videos will pop up on the top right of this video that you're watching at the current moment. All right, people, but if this video helped you to understand how to solve for x using trigonometric ratios, do not forget to like, comment, share, and also subscribe to the channel if you haven't subscribed to the channel. Share this to your friends who are also doing the same subject. All right, people, we are done with 3.2. How about we continue and do 3.3? All right, guys, here's our 3.3. Now 3.3 has two questions, so we're gonna start with 3.3.1, where they want us to derive a formula for cos x over 2 if cos 2x is equaling to 2 cos squared x minus 1. They just want us to derive half angle. Let's do it. So we are given this problem here. They want us to derive half angles here for cos. So it's not really that difficult, guys. First, we are given cos 2x is equaling to 2 cos squared x minus 1. So this is what we have there. So what we have to do here is to make cos subject of the formula first. So what we can do here is to transpose this negative 1 to the left hand side. So let's do it. If you transpose that negative 1 to the left hand side, we're going to be having positive cos 2x plus 1, because this one's going to be positive, and then on the right hand side we're going to be left with 2 cos squared x. There we go. From here we have to divide by the coefficient of cos there, which is 2. If we divide by 2 throughout here, we'll be left with the following. This 2 and that 2, they will divide each other. So on the left hand side we're going to be left with cos 2x plus 1 divide by 2. Let us not forget that. So on the other side here, we're going to be left with cos squared x. There we go. Then from here, we can square root to remove the square there. Let's square root both sides. So if you square root there and also square root on the left hand side, this square and the square root, they will give you 1, the power. And then on the left hand side, you're going to be left with the square root of, let me just continue here, cos 2x plus 1 divided by 2. All this is equaling to cos x. Right. So I'm going to continue here on top. What we need to do here, remember, we are being asked to have half angle. We have been asked to have cos x over 2, which is the half angle. As you can see, we have this one here. It has only x. So what we need to do here, we need to divide this angle by 2. What you do on the left hand side, you must also do on the right hand side. So also here, this angle, you must also divide by 2 there. So if you divide these angles, let me continue here, guys. We're going to have the square root 2 divided by 2. As for the angles, we're going to be left with only cos x there plus 1. All this is divided by 2. That 2 there, please don't forget. And then all this is going to be equaling to, so this is going to be cos x over 2. As you can see, this is what they were looking for. Please be careful. This 2 is only dividing the angle, which in this case, it's only x. So this is basically what they are looking for. They wanted us to derive this formula here. I hope you guys understood how to derive this formula. I've left a video on how to derive half angle in terms of sine and cos. So go and watch that video in the description, and the very same video will pop up on the top right of the one that you're watching the current moment. Go and watch it just in case you didn't really understand how to do this. But if you managed to understand how I've done this one here, please do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. Then if you didn't understand, again, you can always leave a comment in the comment section. I'll try to explain to you to my level best. Right, people, we are done with 3.3.1. Let's look at 3.3.2. All right, people, let's look at 3.3.2. Now the question on 3.3.2, it goes like this: use the formula derived in 3.3.1 to determine the exact value of cos 15 degrees without using a calculator. So what they want from this question, guys, is for us to use the equation that we derive on 3.3.1, which is the one that I left here. Use it to calculate cos 15 degrees without using a calculator. So this is how you're supposed to do it, people. Remember, we have cos 15 there. So we know that we can write cos 15 degrees as cos 30 degrees divided by 2. Wherever there is x, we can put 30 there. So let's do it. So we can say cos 30 degrees plus 1 divided by 2. And then here we can say cos 30 degrees divided by 2. So from here, you need to use the special angle triangles. So let me just write the special angle triangles on the side here. I'm just going to use the one that is required. All right, so here's our special angles. Obviously, we have another triangle that is special angles, but this is the one that we're going to use. Again, just in case you don't know much about these special angles, I've done a video on these special angles. Go to the description. I'm going to leave a video when it talks about these special angles, and also the very same video you pop up on the top right of this video that you're watching at the current moment. Right, so let's continue. Let me first zoom down. All right, so let's look at our triangle then. We have cos 30 there. Guys, cos 30, we know that cos is adjacent over hypotenuse. Now, when you look at 30, here's our 30 here. Our adjacent is root 3. And then our hypotenuse is 2. So we can write this here. We can write as root 3 over 2 plus 1. All of this is divided by 2. Remember, that is cos 30. Cos 30, guys, when you look at this triangle, is the same as root 3 over 2. There we go. Now we can continue from here. Cos 30 degrees divided by 2. We can continue here, people. Let's create a bit of space again. Now if we continue, we still have the root there, guys. Still have the root. We can say root 3 over 2, right, plus 1 over 1, all this divided by 2. The 2 there, guys. Just decided to write it like this. So we have to find the common denominator on the first bracket. So let's find it. LCD. We're going to have 2 there. So we know that 2 into 2 is 1 multiplied by root 3. This is going to give us root 3. There we go. Plus 1 into 2, it's 2 multiplied by 2. That is going to give us 2. Instead of writing this division here, we can write as multiplication. If you write as multiplication, it means that now they're going to swap. You're going to have 1 over 2. 2 is going to become a denominator and 1 becomes a numerator. So let's continue. Let us not forget this is equaling to cos 80 degrees divided by 2. Both of them, they're still equaling to cos 80 degrees over 2. There we go. So from here, we're going to continue and put this under the root. On the numerator, we have root 3 plus 2 multiplied by 1. That is going to give us root 3 plus 2 divided by. On the denominator, we have 2 multiplied by 2. This is going to give us 4. All this is equaling to cos 80 divided by 2. Right. So if you look at this, we can say the square root of 4, which is our denominator, is going to be 2. So we can write this answer like this. We can say root and then root 3 plus 2. All this is divided by 2. And this is equal to cos. What is 30 divided by 2? It's going to be 15. So this is our final answer, guys. Don't go further than this. If you go further than this, it's going to give you a decimal answer. So we rather leave it like this. Besides, it was out of 6 marks. Guys, this question here, it was not as difficult as it seemed. But if you didn't understand your special angles, you didn't understand your half angles, then this was going to be a bit challenging. But guys, this is how you do this. So just in case you didn't understand, please do not forget to rewatch at the point where you got lost. If that doesn't help, you can leave a comment in the comment section. I'll try to help you to my level best. But if this video helped you to understand how to solve such problems, do not forget to like, share, also comment as well, and also subscribe to the channel if you haven't subscribed to the channel. At the end of this video, I am going to leave the playlist of this question paper that contains all the questions of this question paper and also the following question, which is question 4. So just make sure that you wait until the end of the video. They'll pop up there on the screen. All right, people, we are done with question 3. I hope you managed to get it. We will be doing question 4. So whenever you subscribe, guys, do not forget to hit the bell notification so that whenever I upload a new video, you will be notified. Thank you very much, guys, for watching. Till next time, cheers.